Hi guys, welcome to TP Coder channel. For this video, I'm going to show you how do I create a custom model class for our each gender datasets. Let's get started. Hi guys, welcome back to my videos. First thing, we will continue from our PyCharm's IDE, and that in the projects directory, we're gonna create another Python file. So I'm just gonna name it our custom H model from torch.nm import module. Then we're gonna create our class. I'm gonna just name it as custom H model. Then we're gonna inherit our module. Right. So we're gonna create our constructor. Then we're gonna say super dot init. We're gonna say our custom H model, and then self. Then for our custom H model, we are expecting only one parameter to it, which is the device. Then I'm just gonna say self.device is equal to device. Oops, sorry. It should be at here. So the planning of how we're gonna create these particular models is first thing, I will have a common share feature extractor from the images, which we're gonna construct it from CNN. So I'm gonna say first thing, I just need to from torch import nn because we're gonna use this. So I will say nn.sequential. Then I'm gonna pass in the first layer. Is a convolution layer. That how many inputs from our images. So because we're dealing with only grayscale image and the channel should be only one. So the first one input will be just only one instead of three. So the next one will be how many output that we are expecting from this first convolution layer. So first one I will say 64. Then the kernel size I will put 2. So it will be have a 2 by 2 kernel, right? So then after that we will pass into a ReLU activation function. The next one we gonna do is batch normalizations. So we just want to normalize the parameters into the scale of 0 to 1. So you're expecting the input at 64 because the output of the past layer will be 64. So the input for the next layer will be 64 as well. Right, then next, what I'm gonna do is pass in another layer of convolution. So it will be convolution 2D as well. So the input will be expecting a 64, then we pass to a 128 output, and the kernel size, it will be 2 as well. Then and dot ReLU. Then we're gonna pass into a max pooling layer. It will be 2 by 2 as well. Then I'm just gonna do the rest. So then we just want to make sure that it's to device, which if the device is CPU, then we'll pass it to CPU, and if it's GPU, then we will pass it to the specific GPU, right? So we want to make sure it flatten the layer as well, because on the upcoming layers, we just want to make it into a one dimension instead of two dimensions. So we want to pass it to a feed-forward neural network. So yeah, we need to flatten it before we need to pass it to the next layers. Next will be the edge regressor. It will be an end sequential as well. So it will be an end a linear layer. And then the trick here is we want to make our input from the last layer, which is the feature extractor, as a dynamic input, right? So we don't want a fixed size. Let's say we want to change the size of the input into like 2 to the 4 by 2 to the 4. We're still able to change the input layer like without considering the input for the sequential linear layers. So yeah, how can we do that is actually I'm gonna create another function. I will say get linear input, and then we're just gonna make it a empty function first. So I'm just gonna say the input of the first linear layer will be self dot get linear input first. Then how many output that we want. I'm just gonna say the next layer will be 512. Then still the same, we're gonna pass it for a ReLU activation function. Then we're just gonna add another linear layer from 512 to 1024, and then n dot value as well. Then we're gonna say n dot dropout. We want to apply some dropout, so probability will be around 20% of dropout. And then our last layer will be n dot linear, right? So it will be 1024 to 1 to device. Alright, so the next one will be our ethnicity classifier. It will be n sequential. Then I'll say n linear. Same for this. We will just gonna make use of the get linear input functions. Then the next layer, let's put it as 1024 probably. n dot ReLU, n dot linear. And I want to make a deeper layers for this particular ethnicity classifier. Make it as 5 output because we will have 5 prediction classes. So we will have 5 nodes at the end of the linear layers. And we also want to make sure it's to device. Then the last classifier layer will be the gender classifier. it will be n dot sequential. Then the same thing, we're gonna do linear self dot get linear input. Let's put it as 256 and n dot relu. And the output layer for gender classifier will be only one because we are planning to do binary classification for these particular labels. Right, then so make sure it's to device. Alright, our neural network are ready. So the next things we're gonna do. So next we're gonna create the for functions, which is necessary to be inherited from the module class. So you are taking x as a feature as an input. Then the first thing, I'll say x is equal to self.feature extractor. We want to make sure our images, every images coming, pass in the feature extractor first, right? So we come to this layer and pass through all these convolution layer. That, yeah, the next one, we're just gonna return, right? I'm just gonna put it in a mapping. So I will say ethnicity as the first one, right? It will be self dot ETH classifier. Then we are gonna pass in our X. So the next one will be our gender. Then we're gonna import another function called sigmoid because we are planning to do binary classification. Right, so, and also round. Right, then we just want to make sure that we round up the value that are passes through a sigmoid layers from our return classifier. Last but not least, we're gonna do for the age. So it will be just self dot age classifier, age regressor, and then it pass in our x. So yeah, don't forget that we have to pass in our x as well. All right. So the last thing here is we're gonna fill up this get linear input function first before we can actually use our custom age model module. Okay, first we want to create a temporary input. So I will say temp input. That it will be the torch dot random. Right, so I'm just gonna say it's only one, then channel only one, which is grayscale, then 48 by 48, which is our expecting input. And then we want to make sure is to device. Sorry, it will be self dot device. Okay, the next we want to get the output x, I'll say. It will be x self dot feature extractor, then our temp input. Right, so the size will be out x dot size. So the last thing we're going to do is we want to make use of maths library or maths package, right? Then we just return maths dot, we want to get the prod, which is product of it's the size, right? So let's say the output will be 1 times 48 by 48, right? So for the size, it will be in the type of tuples that for each indexes value inside the tuples. So we will times up. We will make a product of each of them. So I will say is that like it will be 1 times 48, 48, and you will get 2034. Right. So this will be the input size for our linear layers. All right. So let's have a quick run on our model. So just to make sure that our model are working. So I will say my model will be custom H model. So temporarily we'll just pass in CPU as our device. So the next thing is from torch summary. Torch summary. That we're gonna do is print summary. Right, and pass in our my models with input of Alright, it seems that our neural network have been successfully created. So we have 3 different output layers, right, and a common use extractor. Okay, so until here, I think we are done for our custom H model. Thank you guys for watching, and I will see you in the next video. Bye bye.